Let's continue to expand our knowledge of linear functions. The next topic is parallel and perpendicular lines. Parallel lines are, well, they're denoted by two vertical lines that look like train tracks because parallel lines never cross. If I have an equation, say, in y equals mx plus b format, y equals mx plus b, and let's put a specific equation to it, say y equals 2x plus 5. What line would be parallel to this line? Well, parallel lines, they have the same slope. That means the slope of the line that's parallel equals the slope of the original line. The m's are equal. So our parallel line to y equals 2x plus 5 might be y equals, it must be 2x. It must have the same slope. And then it could be plus 6. It could be y equals 2x with a 0 intercept. It could be y equals 2x minus 1. It could be any intercept. So the line actually might look something like this, and all the parallel lines to it would look something like that as well. What about perpendicular lines? Perpendicular lines we denote by the following symbol where two lines are at 90 degrees or right angles to each other. How are they related on linear functions or equations? Well, they have what we would call the negative reciprocal slope. And that sounds like a handful, but basically what that means is if I want the perpendicular line to a particular line of slope m, it equals negative 1 over the slope of that line m. Okay? Another way to think about it, if I rearranged it, the product of a line and its perpendicular line equals negative 1. So let's see an example of what that might be for a particular line. Y equals 2x plus 5. Let's start there again. What is a perpendicular line to that line? That would have a slope of m perpendicular equals negative 1 over the slope of the line is 2, so negative 1/2. And that line would be essentially something that would be like that. Now, what would a parallel line to that be? Well, it could be any set of parallel lines. There are infinitely many lines that are perpendicular to the original line. Y equals negative 1/2 x plus 5. Y equals negative 1/2 x with no intercept, and so on and so forth. I could have several lines that are perpendicular to that. So we know parallel lines have the same slope, and there could be essentially infinitely many parallel lines to any given line. But what if I wanted the parallel line that particularly passes through a point, say, 1 comma 1? How would I find that? Let's go back to our original equation before. Y equals 2x plus 5. And I want to know a parallel line that passes through a point 1, 1. There's only one parallel line that passes through the point 1, 1, as we can see. So how do we find that? Well, we again do it the same way we did to solve for our equations before. We plugged in the point we know that lies on the line, and we solve for the missing variables. So in this case, this line here is really just going to be y equals m, which we know must be the same, 2x plus what we don't know is what b is. We don't know what the intercept is, because y equals 2x plus 5 might be the line there. We're going to have a different y-intercept. So I'm going to use the point to help solve for b in this case. So I'll plug in 1 for y and 1 for x. 1 equals 2 times 1 plus, again, we know our intercept is not 5, it's b, and that's what we have to find to get the equation for the line that passes through the particular point. Well, now I can solve for b. Subtract 2 from both sides. B equals negative 1. The parallel line that passes through 1, 1 is y equals 2x minus 1. This is parallel to my original line, but it passes through the point 1, 1. How do we do the same for perpendicular lines? Again, if I had a particular line, I could have any number of perpendicular lines, but perhaps I want the one that particularly passes through a point. let's again say that point is 1, 1. So what perpendicular line to y equals 2x plus 5 passes through the point 1, 1? It's the same process. We're going to say our perpendicular line has a negative reciprocal slope. That's y equals negative 1/2 x in this case. That's the negative reciprocal of 2, the original line slope. X plus, well, again, we don't know what that intercept is, so we're just going to call it b for now. But we do have a point that lies on the line, 1, 1, and we're going to plug that back in for our x and our y. So y equals 1 minus 1/2 x equals 1 at the given point that's on the line plus b, and we can solve for b. I'm going to add half to both sides. B equals plus 3/2. The equation of our perpendicular line that passes through the particular point 1, 1 is y equals minus 1/2 x plus 3/2. And that's how we find parallel and perpendicular lines that pass through specific points. In those cases, there are only unique lines that pass through them.